We have question number 62. It says P is some kind of monic polynomial with a degree n and k is a real number. So which of the following statements are true? One says if k is greater than 0, the register point p of x naught is equal to k times e power x naught, that is the polynomial and the exponential function intersect. Similarly, we have options 2, 3, and 4 with certain conditions. We'll check them one by one. So the first option says k is positive, k is greater than 0. So the function is k times e raised to x. If you draw the graph, since k is positive, it will take the value just like at 0, it is just like a k e raised to 0 that is equal to k. So it is an exponential function passing through k, and as x tends to infinity, it goes to infinity, and as x tends to negative infinity, it goes to 0. So the graph looks like somewhat like this. Now we have the p monic polynomial where n is even, the degree of the polynomial is even. Since p is a monic polynomial, the coefficient of the leading term is 1, and given it is of degree even, so to the simple case we can say let it be x square. So it is a monic polynomial and the degree is even. If you draw the graph of x square, it may look like somewhat like this. So it clearly touches at a point, say x naught. So k e times x naught is equal to x naught square. That is p of x naught. So it satisfies. Does this mean for every n, when n is even, does it satisfy? You can see from the graph, for any x raised to n, it doesn't matter if we have extra terms. If n is even, as n tends to infinity, it goes to infinity. The graph, it goes to infinity. There can be certain ups and downs here if there are certain terms. It doesn't matter. All it matters is as x tends to infinity, this goes to infinity. And since n is even, as x tends to negative infinity, it goes to infinity again. It's something like this. Since we can see definitely there will be a crossing somewhere because it crosses, because as the first function k, the exponential function goes to 0, the other one goes to positive infinity, thus they will meet anyway at least at one point. But what happens if it is just like x square plus some value greater than k, say k plus 1? So as x, or if x equal to 0, we have the point at k plus 1 position. So the graph will look like it goes above like this. So the exponential graph and the polynomial graph doesn't touch at the negative part of x-axis. You see the negative part, it will never touch because it goes to infinity and this goes to 0. There is no way it is going to meet. But we know that the exponential function increases exponentially, which is much greater than that of a polynomial function, so that as x approaches infinity, this exponential function reaches infinity in a lot quicker than that of polynomial function, which implies just like they will cross somewhere in the positive. x-axis. So in either case, both the graphs meet at least at one point. Thus, first option is correct. Now the second option says the power of the polynomial function is odd. We can take say x, since this is monic polynomial as well as the power is odd, and given k is negative. So if we draw the graph for the exponential function k power x, what happens when k is negative? It is just like the reflection over x-axis. So the graph will look like, somewhat like this, and this point will be, k. K is in negative. Now, if you look at the polynomial function, the function is has the leading coefficient was 1, and it is odd degree. Thus, as x tends to infinity, the polynomial tends to infinity. There is no doubt in that. Let it say, okay, we'll use some different color. Say it will reach infinity somewhere like this. And since this is of odd degree, as x tends to negative infinity, the polynomial function here, x itself, it tends to negative infinity. So it will be somewhere like this. And this is continuous, so there can be many ups and downs in the function depending on the terms after it. Say this is just like x power 100 plus x power 99 plus, there will be certain, derivative can be 0. But anyway, since it reaches positive infinity and it reaches negative infinity, it will touch this exponential function at least one place, because there is no other way it can jump above it and reaches infinity, because polynomial function is always continuous. Thus, p of x naught is equal to k times c of x naught for some x naught. The second option is also correct. Now the third option says n be any natural number. It doesn't matter n is odd or even, and k is a positive number which lies between 0 and 1. So if you draw the graph, it doesn't matter if k is less than 1. Say it is 1, k will be somewhere around here, say here, but the function looks like just the exponential function itself. Given n, the polynomial function is a natural number. So let me take n be 1. We are going to get a counter example. So the function looks like x. Okay, x will be somewhere here. There is a possibility such that the function f of x can touch the axis. So I say I take the function as polynomial function as x minus 1 lakh. So it will be deep down, below somewhere here, and this function, the graph will look like, somewhat like this. And we know that exponential function, it reaches infinity very fast, and x has a slope 1, and it doesn't reach infinity as quick as the exponential function, which means it will never meet. These functions will never meet, whatever way. So we can say there does not exist, does not exist x naught such that they touches each other. We don't have such x naught. So third option is wrong. And fourth option, You can take this example as an counterexample to claim fourth option is also wrong, because we have taken n to be 1, so it is odd, and we have taken k be some number, say zero point 0.8, and we have shown that it satisfies all the conditions in fourth option, but uh, the graph doesn't meet each other, or there does not exist any point which satisfies this equality. So we have option 1 and 2 to be correct, and 3 and 4, it's not correct.